Okay, moving on to the next part of chapter 2, we're talking about conditional probability. So let's just sort of recap how we thought about conditional probability at GCSE. So if you had a tree diagram like this, let's choose an easier example. So maybe we have something like boy, girl, and we have two subjects, let's say French and German. You might remember that we multiply across the branches for a tree diagram to find probabilities. And then we had a variation which was normally using the word given. Okay, given tends to be the word that's used. And we sometimes said things like, given that the student picked was a boy, what's the probability they picked French? And instead of using a denominator talking about all of the people, the denominator then was out of the number of boys. So it sort of restricted the situation. That's conditional probability, that idea. So this is the formal notation. So this here says, what's the probability of B given that A has happened? So that's doing the same thing. It's saying, really, we're starting from here, okay? And then what's the probability of B? So it sort of means you're zooming in, you're focusing on one part of your diagram, I suppose, okay? And we've got one of our rules here. So if we wanted to find the probability of A and B, this is equal to the probability of A multiplied by the probability of B given A. And it can be written like this as well. And if I just quickly move over here, let's go back a little bit. This one is in your formula booklet. Okay, so the probability of A and B of A and B is equal to the probability of A multiplied by the probability of B given A. So this one you don't have to remember this one. This is in your formula booklet. Okay, so we're going to be working with conditional probability here. Just to describe the rest of the diagram, so this means A, this means not A, this means B, this means not B. So that's the complement that we talked about earlier. Okay. So some examples here. We've got two-way tables. We've got Venn diagrams. Let's have a look at working out a few of these probabilities. So the two-way table shows foreign languages. So B is the probability that they are a boy. So boy and not boy. F is the event that they choose French. So French and not French. Out of 100 people, let's find the probability of that they study French, given that they are not a boy. So I would probably go straight for a method like this. I would be thinking, well, we're talking about out of this group here, out of the not boy group. So we're looking at this column here. And then what's the probability that they study French? Well, it's 38 out of 60. So if there's a diagram, that would always be my go-to. Okay, I would always try it that way. We can use the formula though. If you write down the formula, okay, we can find the probability that they study French and that they are not a boy, and we're just repurposing this one here. Okay, so we just change B to like the complement of B in this case, so that is the complement of B as well. So you could use the formula. But like I said, I think that's more complicated in the situation than this. So if there's a choice, the diagram might be the way to go. Then we've got another question here. So this basically stresses that the order is important. So given that they do not study French, in other words, we're looking at this row here, what's the probability that they are a boy? So it's 14 out of that row, which is 52. Oh, sorry, I picked the wrong row there, didn't I? Sorry. Given that they don't study French, I should have been picking that row there. Okay, so it's this row here is the not F row, and then boy is 26 out of 48. Venn diagrams. So let's have a look at it with Venn diagrams. So what's the probability of A given that they belong to B or it's B already? Well, if you know it's B already with the diagram, you start off with that part. So you always start off with this part here. You start off with the given part. Okay. And that effectively just sort of restricts down the diagram, the sample space. So it's out of 6, yeah, because it must be inside B. So it's out of 6. Well, what's the probability of A? Well, it's 2 out of 6. So if I had a choice, that's the way that I would do it. Again, we could use the formula. So the formula, we've got this one here. Okay, so that's the one that we want. We've got a couple more here. So given that it's not B, so notice again, I'm reading this part here. Given that it's not B, in other words, it's this or this, yeah, it's not B. Given that it's not B, what's the probability that it's not A? Well, it's 3 out of 9. Okay, so if you have a good diagram, this might be the way to go. Given that it is A union B, so given that it is inside one of the circles at least, what's the probability it's B? So 6 and 4, so that's 12. The probability it's B should be 6 out of 12, shouldn't it, or a half? Okay, we've got a few more examples. So another one, maybe there's no diagram. Maybe you just have these ones here, and you just need to use the formula. Okay, so A and B, and you've got this one here. Okay, so you just plug those numbers in. Sometimes that's the way to do it. Something like this one here, saying it's giving us the hint that we could draw a Venn diagram. So let's do that one there. So what we're talking about, X's and Y's. Assume that they overlap to start with, at least. So intersection is 0.4. And y adds up to 0.6, so that's a 0.2. What is the probability of not x given that it's y? So I know we don't have the rest of the diagram, but we might not need it. Given that it's y, so it's out of this 0.6, yeah? It's out of this 0.6. What's the not x bit? Well, the not x bit is the 0.2, so it looks as though it's going to be a third. Okay, and then we got one more. So it seems like we've got a lot of information on this one, so maybe we draw a Venn diagram again. So intersection is the best place to start, is 0.4. That's A and that's B. A should add up to 0.5, so that's 0.1. B should add to 0.5, so that's 0.1. So we can do this one as well while we're at it. So that should be a 0.4. And what do they want? What is the probability of B given that it's not A? So start with the given that it's not A. So A is 0.5, so everything else must be 0.5. Yeah, this one and this one. The probability is B, well, it's 0.1, isn't it, out of the 0.5 that's left? Or, a fifth, 0.2, something like that. So pause here and just have a quick go at these ones. Okay, so E and F, 0.17, F, 0.65, and then our conditional probability, so they've used the formula here. Okay, and that could all be done with the Venn diagram. So if you went down a Venn diagram path, what you could have done, let's have a look. So that the thing is E and also not F is 0.11. So that's where you would have started. And then probability of E, so you would have made sure that these two numbers together add up to 0.28. Then this one means everything inside the circles. So you've got 0.28 already. So the only bit that's left is there. So you could have worked that out. And then it should add up to 1. So if you had done the Venn diagram to start with, that would be the way to go. Okay, we've got a few more questions. So what have we got here? Probability of A and not B. So I'm going to just draw Venn diagrams. I mean, this is the way I would do it. So A and not B. So that's this shape here that doesn't include the intersection. So that part there is 0.4. So that looks really complex, but that's a nice detail to be given because you can just write that number in straight away. The whole thing has to add up to 0.75. So what does that tell me? Well, that tells me the total probability of B, which should be 0.35. Yeah. Now, I can't work out what the intersection is exactly, but I know what that bit alone is, and I know what these two parts together is. That's how I've found that one there. Well, how could I work out this one? So the probability of not being A, so not being inside the A circle, and not being in the B circle at the same time, well, I'm actually describing the area on the outside, aren't I? And if the area inside is this, then the area outside must be 1 minus that. Okay. So if you're not sure about these, I just suggest that you go back to the lesson before and you have a look at some of the set notation. So pause the video and have a go here. You have already done part A. You did part A in the first video. So part B now is using this conditional probability sort of stuff. So start with C. It's my advice. Restrict it down to C, and then look at the probability of B from there is what I would do. So pause the video and have a go. Okay, let's take a look then. So we could use the formula here. So in this case, we're using the formula. So we can do, given that, okay, yeah, because that makes sense. We were given this number here, so we wanted to use this one straight away. So we've got that. The overlap of B and C, that's that one there. Okay, and C means everything inside the C circle. So that's 0.2 plus Q. So you can find Q. And then once you find Q, well, you've got P, you've got Q. So R is about the idea that all of these bits should add up to 1. And then part C is about using your final diagram. So given B, in other words, given that part there, so out of that 0.4, if you like, what's the probability that it's in A at all, or that it's in C at all? So that should be 3/4, okay, because it's 0.3 out of that 0.4. So if you're using the formula, you're just effectively using the diagram. But sometimes some situations are probably better for the formula, some are better for the diagram. You should make sure really though that you have this one to hand when you're working through these questions, because it will come up quite a lot. Okay, and we actually, yeah, so we've done 2B and 2C there together. So I think 2B is more about the diagram in the book, and 2C is more about using the formula. But I would base it on the situation, which one's most appropriate to use.